Gradle 7.6 contains some exciting updates. Here's an overview of the major changes. For more details, check out the longer format video linked in the description below.
For the configuration cache team, most of our contributions for 7.6 were on bug fixing. A couple of them were related to how we handled errors and how we reported errors. In 7.5, sometimes some kinds of dependency resolution errors would lead us to save a failed outcome in the cache. And even if the cause for the dependency resolution went away, if it was a transient issue or something like that, we would not actually be able to recover from that. We would be stuck in a bad state. So that was improved, and you now do the right thing for that case. In terms of reporting failures, we used to report separate entries if you had a failure during a cache store operation. We would report the root cause, and then we'll also report the configuration cache store problem with the cause repeated in there. So there'll be a lot of duplication, a lot of noise, and that has been changed. So the output now looks a lot like what you get if you run without the configuration cache running. And any insight about the source of the problem appears as part of the message for the failure. We extended compatibility for configuration cache some report tasks. The tasks you see there, they would fail either at cache store time, or sometimes it would work fine for cache store time, but it would fail at cache load time. And all the problems there were variations of us trying to serialize things that are not serializable in the configuration cache. So those are all fixed now. They are configuration cache friendly. We have a few plugins that do not work with the configuration cache still. Maven publish plugin was one of them up to 7.5, and now it does work. In 7.5, if you attempt, for instance, to publish to a Maven remote repository, the publishing would work, but it would fail to store the configuration in the cache. For 7.6, we fixed that so the publishing works, and the state that we need for our configuration time later for execution time is properly serialized. We changed the way offline is handled in the presence of the configuration cache. In some cases, people wanted to execute different configuration behavior depending whether they were running offline or online. Up to 7.5, that was not possible. You would cache the configuration with whatever mode you run. If you change the mode later, you would restore the previous configuration. You would not have the opportunity to execute different behavior. Now, configuration cache entry for online mode is separate from the configuration cache entry for offline mode. We implemented support for rerunning a single task up to 7.5. If you run some build and, for instance, you compile your code, you run your tests, and you want to rerun your tests. For Gradle, nothing needs to be done because everything is up to date. But if you really want to rerun it, you could use the -- rerun task option. But that has the caveat that it actually reruns all the tasks, not only the one you want to see rerunning. So we added support for a -- rerun that can be specified after any task, and it reruns that task specifically. Sometimes rerunning a task will require other tasks that depend on it to rerun, but other than that, everything else should not be rerun.
All right, hi everyone. The first change I've got for you is about converting Maven products to Gradle projects. So in Maven land, there's no difference between a compile scope dependency that's strictly internal to the library being compiled and a dependency that consumers of the library will need when they compile against the library. So they both use Maven's default compile scope, and they're both propagated to any projects that depend on this one. In Gradle, we do make this distinction. We have API versus implementation, and we can avoid exporting dependencies that aren't part of a library's API as transitive compilation dependencies to downstream projects. So Gradle's built-in init plugin has a mechanism for converting an existing Maven build to a Gradle one. So you run the init task. This plugin previously mapped all the Maven compile scope dependencies to Gradle implementation dependencies. So this means they were not available to downstream projects at those projects' compilation time. So if you had two Maven projects, A and B depends on A, you convert both of these to Gradle, and there's a library used in A's public methods that was not an explicit first level dependency of B. B now might not compile due to a missing dependency after you convert both A and B to Gradle. We've changed this to now map both of these dependencies to Gradle's API configuration. So it's important to note that, because Maven doesn't have the ability to specify which behavior is the correct one for each dependency, both choices of how to map are potentially wrong. Right? If we take Maven compile scope, we could put it in API, we could put it in implementation. Both could be wrong, but they'll be wrong in different ways. The new way of using API improves the chances that if you're converting a series of projects that have dependencies upon each other, they will all still compile. The former way would have the advantage of preventing some dependencies for leaking, which weren't actually needed for downstream compilation. But we think it's more important that your projects still compile after you convert them. So we made this change. I know it's still not a guarantee that you'll get Gradle projects that compile after converting, since there might be other dependency conflicts or issues that this mapping creates. But we do think this will happen less frequently, and that these sort of errors will be easier to fix and be a better outcome in general than causing projects to suddenly stop compiling because of these vanishing transitive dependencies. But as always, the best thing you can do is, inspect the dependency declarations in your generated build script after conversion and verify everything you've added to the API configuration is really a part of your project's API. Otherwise, move it back to implementation. If you are using variant-aware dependency resolution and you can't find an exact match for all the requested attributes, but compatible attributes exist, we could potentially match several variants of your dependency. So no two variants are allowed to possess exactly the same attributes. This could be a duplicate exact match, and that would be a problem. But multiple variants of a project can exist with different but compatible attributes to those requested. If there's no exact match for a request, but a single compatible variant does exist, problem solved, we use it. If multiple compatible variants exist matching the same number of attributes, we need to choose one. So in example 2 here, we've exactly matched one attribute and found a compatible variant for the other attribute. So when a human tries to select between which of these two compatible variants we want to resolve, we intuitively understand that there are more important attributes, and we should look at those first and try to find exact matches there. So in this case, maybe flavor is more important than temperature when we're selecting a beverage. So choosing between several compatible variants is done programmatically by disambiguation rules. So in Gradle 7.5, we added a way to define the order that these disambiguation rules are applied. Prior to that, there could have been issues with a scenario like this where, is it more important to find a exact match for flavor or for temperature? For which attribute should we look at first when we're disambiguating? In Gradle 7.6, you can view the order of these disambiguation rules when you run the resolvable configurations report. So you'll see the ordinal in parentheses there for all the rules that have a precedence explicitly defined.
Gradle now supports being run with Java 19. One thing I do want to call out is that this is not the same as compiling or running tests or anything like that with Java 19. You have been able to do that since Gradle 7, and all you need to do is use a toolchain to actually get a 19 JDK in your build. But now you can actually run Gradle with Java 19 JDK in your Java home, and it will just work. Next feature is type-safe dependency blocks in test suites. So this is about this dependency block here that is inside your JVM test suite. This is not the top-level block. And as you can see here in 7.5, its type is JVM component dependencies, accepts all of these different notations that you would expect: a string, project dependency, version catalog, libraries, and bundles. But as you can see, my IDE is telling me that these are all going to have a type of dependency when I try to configure them. And that means that there are a lot of missing things, like being able to set particular attributes on these dependencies that I want, or perhaps saying that we shouldn't have a particular transitive dependency because that's all information that is on subclasses of dependency and not the dependency itself. So now in 7.6, this has been changed. So you can see now we have external module dependency or project dependency, or again, external module dependency for version. And these are all possible to now just configure without needing to cast or anything beforehand. And the other thing is that we've also changed bundle due to the way that this typing works. So you will have to write implementation.bundle in order to add bundles in this dependencies block. And this is more of an overview of just like what exactly has changed. We did not change the top level dependencies block in any way. It works exactly the same as it did before. But for this test suites dependency block, it has overloaded methods instead of just taking object like it used to. So we will take string, or we will take a provider of a dependency, anything like that. There is IDE feedback on what types you can pass in, because we now have overloads for each individual one, and you don't have to go look it up in the docs anymore. And also, Kotlin DSL can now, as you saw previously, it can type the configuration lambdas for all of these dependencies, and you'll get IDE feedback right there.
With this release, incremental compilation now works also after a failure. This is implemented for Java and Groovy, and Kotlin already supports that from before, thanks to the JetBrains team and Kotlin team. Here we have an auto-generated project with 4,000 Java files, and right now we're running Gradle 7.5 and everything is up to date. So let's make an error. So yeah, we can see we forgot the semicolon, common mistake, and build failed. So yeah, after we fix the issue, what we get is we got full recompilation, and compile Java takes how much? Around 8 seconds. Alright, so build is 8 seconds. So here we have the same project, so the same number of files, but this time we're running with the Gradle 7.6, and again everything is up to date. So let's make the same error again. Yeah, we forgot the semicolon again. Yeah, what can you do? And after we fix the issue, yeah, this time build is much faster. So it's just 2 seconds and we got incremental compilation.
This is about the toolchain auto provisioning plugins. Basically, this is a need which came up with changes happening to the adopt OpenJDK hard-coded repository we used since for past versions for downloading toolchains when needed. It turns out that it's not a good idea to have Gradle's lifecycle coupled with the support for these repositories. So we came up with support to write plugins, specifically settings plugins, which provide definitions of such repositories, and then those can be worked on separately from Gradle. Before 7.6, we only had as I said, the hard-coded version. And then in 7.6, we implemented the optional feature of defining other plugin-based repositories. And this becomes actually mandatory after 8. But in 7.6, we have both this new way of declaring things and the legacy repositories. One thing to mention, because I've noticed often that people think that this feature affects the whole toolchain feature of Gradle. It's not. It's only specific to provisioning toolchains, which should be a relatively rare occurrence of the whole functionality. What these plugins provide, the repository definitions that are provided are just basically a mapping from a toolchain specification to a download URI. You also have at settings level definition, which you can see on that code snippet, where you can declare an ordered list of such repositories because the order of it matters. It also has the full authentication support, which we have for the regular type of repositories. So this is not really strictly tied to the 7.6 release now that we have decoupled from it, but we already have released our official or one implementation of such repositories. It's at that link provided, and it's based on the FooJ Discovery API and provides a pretty extensive list of JDKs you can download.
In 7.6, we merged a feature contributed by the community that introduced the configuration of a network timeout for the distribution download by the wrapper. It was hard-coded to 10 seconds before, and in some environment, this wasn't convenient and causing problems. And so now you can set your own timeout, and you can see you can do that on the command line, in the DSL, or in the wrapper properties.
So this change was also contributed by the community. It adds a new API on the task, and this can be used for explaining why a task was skipped. You can pass a string reason message to the onLeave methods, and this is similar to some of our APIs that already provide this capability. You can see how the reason is logged in the build output. The other change is a fix for lacking support for debugging over network with Java versions 9 and above. Now we have new APIs in Java debug options, and it's a host property which you can use to set the host name if you actually want to debug over the real network. In Java 9 and above, you can specify the host name special value, that is the asterisk, and it will make the JVM accept debugger connections over any of the network interfaces that you have. And if you don't want that, you can actually just use any of the host names that your machine has, and it will only accept connections on that interface. In addition, we also have a new Gradle daemon option, which is for debugging the Gradle process itself over the network.
Hi, I will explain what changed in Gradle 7.6 with regards to tooling. In this release, we focused on IntelliJ IDE integration. We implemented several missing features reported by the JetBrains team, specifically how system properties are controlled and how can tests be launched via the tooling API. Let's begin with the system properties. Before Gradle 7.6, system properties from the IDE appeared in the build process, which has a potential to break the build. In Gradle 7.6, we introduced a new withSystemProperties method, which IDEs can use to specify what system properties should be visible for the build. This is available for all build invocation types, running tasks, reading build configuration, and so on. Now let's talk about the test launcher improvements. Due to limitations, IDE still uses task execution combined with init scripts to launch tests with proper filters. The biggest problem with that this breaks the configuration cache when the init script changes. In Gradle 7.6, we implemented all the missing features to identify test assertion and test framework failures, to run test tasks along with other tasks, and to declare custom test filtering. Let's see the test failures. The tooling API sends events to notify the IDE about the build progress. The test failures are represented with objects of type failure. In Gradle 7.6, we added sub-interfaces to this failure type. The generic failures and the assertion failures are represented with the test framework failure and test assertion failure types, respectively. The detection is implemented for each supported test framework, JUnit 4, JUnit 5, and TestNG. Also, custom libraries are supported via standard failure types. So, for example, when Gradle sees a test throwing a custom exception that is a subclass of OpenTest4j assertion failed error, then the IDE receives an event object with a test assertion failure instance. The second new test launcher feature is to run tests along with other tasks. It's a common command line scenario which was plain missing from the tooling API. In Gradle 7.6, we added the forTasks method to the test launcher interface that finally fills this gap. The last implemented feature is custom test filtering. The test task can be configured with custom filter patterns, which can be done in the build scripts and on the command line, but not via the test launcher interface. In Gradle 7.6, we added the withTests4 method, which allows IDEs to declare custom filters, such as test classes, test methods, packages, and custom test patterns. That's all. Thank you.